Hi everyone, my name is Frazer Seymour. I'm the Mesh Engineering Lead at the Mesh project, and I'm here to talk about Git branching, merging, and rebasing. So this is going to be a bit of a Git 201 talk. It's going to assume you know kind of what Git is and what it's used for. Maybe you've used it in school or at work, but you don't know the fine details. I'm going to go into a bit more of that today. So Git can be described as a directed acyclic graph, partially because it sounds smart, and partially because it gives you a more nuanced understanding of what's actually happening with these concepts like a commit and a branch. So let's break that down. So in a graph, you have what you can call a vertice or a node, which would be the commits, and they're connected by an edge, so just like a pointer from one node to another. So that's a graph. Directed just means that these connections have a direction. So in Git, that's always backwards. So this commit came after this commit, which came after that commit, and so on, which makes sense because you're saving your work. So you're always like making a new change that came after an old change. Acyclic matters less. It just means there's no cycles in the graph, so you can never loop backwards. So if you start from one commit, you'll never wind up back at that commit by following these paths. So this is a commit. It exists, it has a connection to another commit. So what's a branch? So a branch is just like a label that points to one commit, and then obviously that commit points to all the commits that came before it. So there's one branch called master, which is the first branch that's created. So if you only ever use one branch, you'll just always be committing to master, and master will just point to the most recent commit that's happened. So master just always follows the most recent commit. So what happens if you have another branch? So let's say you want to develop a feature separate from the master branch. You do what's called a fork, which means you come off of like the main branch, and then your branch, let's call it feature, will point to your commit, which will eventually work its way back to the shared kind of tree that you forked off from. So what happens when you check out a branch? There's a special label called head, which points to the commit that you're currently working on. So if you say git checkout master, head will point at the same commit that master is pointing at. And then when you make a new commit, it'll know to point that new commit at the most recent, like at master, right? And then it'll update master and head to this new commit that you made. So if you say, so let's say you're on master and you say git checkout feature, head just points to the commit that feature points at, and then any new commits you make go on to the end of feature. So that's commits and branching. Let's talk about merging. So you've made your changes in your branch. How do you get these changes back into master? So the easiest way is through what's called a merge. And there's two kinds of merges. The first is when you have a scenario like this where you've branched off of master and you just want to merge your changes back in. And all master has to do, like all Git has to do is say, oh, master's up here now. We can just, it's what's called a fast forward merge because we can just fast forward master up to your most recent change. So that just, yeah, we can say, oh, master's up here now. Success. The more complicated case is when you made your changes and then someone else also made changes. So someone else branched off of master, and then in the meantime, you did your fast forward merge, and now master is pointing at your commits. This person can't do a fast forward commit, because fast forward merge rather, because master is up here. It can't just move on up to their branch. So in this case, we have to use what's called a merge commit. So a merge commit is a special commit that points to two different commits, so that you can just say, yeah, we merged this branch into that one. This is all the code that came before. Now, the problem arises when there's what's called a merge conflict between these two branches. So when they both modify the same part of the code. So let's say there was the word cat, and this branch changed it to dog, and this branch changed it to rabbit. It's like, okay, what word do we want here? Do we want dog or rabbit? Which one's correct? Git can't make the decision, so it forces the developer who's doing the merge. Whichever they decide, dog or rabbit or something else, that change is reflected in this commit. So this commit modifies like the combined results to be the new, master branch. So then what's rebasing? Rebasing makes it so that every merge can be a fast-forward merge, which has some benefits that I'll talk about at the end. So in rebasing, what we want to do is make it so that we can just easily move master to the head of feature 2. So how we do this is we want it to look like feature 2 came after we made those changes in feature. So rebase comes from changing the base of this branch to point somewhere else. So how this happens in Git is it will, what it calls rewind heads, will go back, and then it will try to apply each of your commits to this new master. The benefit of this is that if there's any merge conflicts, like the cat and rabbit thing we discussed earlier, you fix it as it happens. You don't have to fix all of your changes like at the end of your branch at once. You can change each small one as it happens, and that'll propagate through and make your life a little easier. So it's as though you applied each commit after, master. Like master was merged and then you made these new commits. It's worth noting, however, that commits have a hash, which is basically a summary of the contents of the commit and the previous place that it pointed. This hash is how you identify that commit. It's like the unique name of that commit. When you change where a commit points, it changes that hash. So it's worth noting that when you rebase, you fundamentally change, let's just say ABC, these are the new commit hashes. You fundamentally change what the commit is, like it's a new commit. But once we've changed this base, now if we want to merge feature 2 into feature, we can do another fast forward merge, and master can just update to point down here, and life is easy. So why would you use a merge instead of a rebase? So there's pros and cons to both, and different debates about the different pros and cons. What a rebase lets you do is see what the master branch is going to look like before you update master. So when you rebase, you are only modifying your branch, right? You change where the base is and updates your commits. So you can test what that's going to look like. You can fix it as needed, and then when you're all set and done, you know it works, you can just change master. Some of the opponents of rebasing don't like the fact that it modifies history, which some people aren't a fan of in Git. Like they think Gits should be kind of preserved as they are. It's also more complicated. It's a tricky concept to learn. You have to understand all this weird graph stuff. So it can be a lot easier to merge. However, when you merge and you have a merge commit, you have to fix the results of all your changes in your branch at once. And you don't get to see what that end result looks like until the merge is done, right? So you kind of don't get to see that result, and you don't get to test that result until after the merge. So for this reason, it can be a good idea to rebase so that you can have tests. However, it can be a good idea to merge if you want something simpler and you don't want to modify history. Hope that helps. Thanks a lot for watching.